Hey guys, let's take up Checkpoint 2016's paper 2. This is a calculator paper, so a calculator is allowed. This first question is a proportionality question. As we see, the value of x and y are directly proportional. Complete the table by filling in the missing numbers and find the equation connecting x and y. Now, the first thing I think about when I see the table like this is a table of values, and I would generally look for a pattern in a table of values when I've got the x values 0, 1, 2, 3, and I've got my y values that go along with it. But as you can see here, they didn't give us a nice, clearly laid out pattern, neither for the x values nor for the y values. So we're going to use proportionality for this. And proportionality is based on the idea that one value is some multiple of the other. So I'm going to start like this. I'm going to say that y is some number, so k is some number, multiplied by x. Now this is the general notation for proportionality, where we say k is the constant of proportionality. It's the value that we need to find to see that y is always that multiple of x. Now in order to work out what that proportionality is, we can use an x and y pair of values that belong together. So when x is equal to 3, y is equal to 96. So now, substituting those values into this proportionality formula, we can work out what k is. So when x is equal to 3, I put 3 in the place of the x. Y is equal to 96, so I put a 96 in the place of the y. And k3, or 3k, they're being multiplied together, so I can just write that as 96 equals 3k, which means k on its own, I'll have to send the 3 to the other side. Here it's multiplying, so the other side will be dividing. 96 divided by 3, and that's 32. So k is 32. Now don't think that we're done here. That's not our answer to this question. That's just helped us to figure out what the constant of proportionality is. So I now know that y is equal to 32 times x. So whatever the x value is, y is 32 times that value. So when x value is 3, y was 32 times 3, which is 96. So now we can use this formula to work out the x value when we know the y value, or work out the y value when we know the x value. So let's start with this first one here, when y is equal to 128. What is x? So I'll put 128 into our formula that we now have, and then we'll rearrange it to find out what x will be. So I replaced y with 128, and to get x on its own, I'll need to divide by the 32, and 128 divided by 32 is 4, so x is 4. When y is 128, x is 4. You can try that if you want, just to check that works. 32 times 4 does give you 128. So let's go ahead and put our answer in the table here. 4. Next, when x is equal to 30, what's y? Again, we've got our formula here. Let's just substitute 30 into our formula. So when x is 30, y is equal to 32 times 30. I've just replaced the x with 30. Notice I use brackets here specifically so that we don't write that this is 3,230. It's 32 times the x value, so 32 times 30. And that's going to be 960. So when x is 30, y is 960. Find the equation connecting the x and y. Well, we did that at the very beginning, and that's what helped us to fill in the table. Our equation that connects x and y is that y is equal to 3 times x. Next question is a volume and metric units of measure question. And I can guess at what you guys have done wrong here. They gave you the length, width, and height in centimeters, and then they asked you for the volume in cubic meters. The first thing you should be looking at is what are the units of measure for my answer, and make sure you've got the right values or the right units of measure for the values you're going to use to calculate that answer. So convert units of measure before you calculate the volume. 120 centimeters in meters is 1.2. Hopefully we all know that it's divided by 100. I don't think that's where our mistake is coming from. 60 centimeters in meters is 0.6 meters. Again, I divided by 100. And 75 centimeters in meters is 0.75 meters. Now that I got all of these values in meters, I know that the volume of a cuboid is length times width times height. Now it doesn't matter the order that we put this in, but we're going to multiply them all together. So I'm going to do 1.2 times 0.6 times 0.75, and that gives me 0.54 meters cubed. Now that's my answer. But since you're asking me to go over this question, I'm going to take a guess that that's not how you worked it out. I'll bet a lot of you didn't look at the units of measure for the answer before calculating it, and you just went ahead and calculated the volume in centimeters cubed and then tried to convert that. It's not as simple as you think, and we will get into that a little bit further on. So if you had done it this way, you did volume is length times width times height, but you used the values in centimeters, so 120 times 60 times 75, you would have gotten 540,000 centimeters cubed. Then I'll bet what you were thinking is to convert centimeters cubed to meters, I'll just do like I always do, divide by 100. Centimeters cubed to meters cubed conversion is not a division by 100. Here's the trick, and I know we need to get into this, but when you're converting a three-dimensional measure into another three-dimensional measure, you need to use the normal conversion cubed. So normally from centimeters to meters, I divide by 100, but from centimeters cubed to meters cubed, I divide by 100 cubed. That's dividing by 100, dividing by 100 again, and dividing by 100 again. Now be careful, that is not dividing by 300. That's dividing by 1 with 2 zeros, 2 more zeros, and 2 more zeros. That's 6 zeros altogether. That's dividing by 1,000,000. So that's going to give us 0.54 meters cubed. See up here, I divided by 100 once, I divided by 100 twice, I divided by 100 3 times, and my decimal is in front of the 5. So 0.54 meters cubed. Another question of proportionality. It's surprising that they try to trick us out with proportionality more than once on this test. In fact, we're going to take up 3 questions like this in this one test. So again, we know this is proportionality because they tell us in the question, quantities x and y are in direct proportion when x is 5, y is 30. Okay, so in direct proportion, that means that y is some multiple of x. You could say that x is some multiple of y, but as you see that x is smaller than y, it would have to be some fraction that we multiplied by 30 to get 5. So I'd rather write my formula in the other way. Y is equal to some multiple of x. Okay, so I've set up my formula for proportionality here, and if I increase the x value, then the y value is going to increase as well, because it's just some multiple of the x value. So if x increases from 5 to 20, then y will increase, decrease, or one of these numbers. It will increase. They are directly proportional. There's also something called inversely proportional, but we won't get into that this year. So we'll increase. From 30 up to, okay, so when x is 5, y is 30. When x is 20, what will y be? Let's use our proportionality formula. So first of all, when x is equal to 5, y is 30. Let's substitute those values into the formula to work out what our constant of proportionality is. That is, let's work out what k is. So when y is 30, I put 30 in here. X is 5, I put 5 in for x. 30 is equal to something times 5. I'll bet you could guess at it, but let's show the working. I want k on its own, so I'll move the 5 to the other side. I'll do 30 divided by 5, and that's 6. So k is 6. Y is equal to 6 times x. Now we can clearly see that they are proportional. Y is 6 times x. So when the x value has changed from 5 to 20, so instead of 5 in here, we'll put 20 in here, the y value will definitely be bigger than 30. Y will be equal to 6 times 20, replacing the x with a 20, and 6 times 20 is 120. So if I increase x from 5 to 20, then y will increase from 30 to 120. Right, next question is a speed, distance, time question, and I can see where this might have been confusing when they gave you hours as a mixed number. But I'm hoping that you can clearly see that a quarter is 0.25, so 2 1/4 is 2.25. Let's set out the given information first. Given that we know the distance is 180 kilometers and the time in hours is 2.25 hours, we want to keep it like this. We don't want to convert it to hours and minutes because we want our answer in kilometers per hour. So speed is distance divided by time. That's 180 divided by 2.25, which is exactly 80 kilometers per hour. Not as difficult as you might have thought, 80 kilometers per hour. Now, this is a graphed simultaneous equation. So you've got two equations here, x plus y equals 50 and 2x plus y equals 60. You do not need to work these out algebraically. They have graphed 3 lines here, so to try and trip you up, 2 of those lines represent these 2 equations. Now, the solution to these simultaneous equations is the x and y coordinate that falls on both of these lines. So that's where these 2 lines will cross. Let's start by working out which line is which. Now, this format for the equation of line isn't very familiar to me. I don't really know what that looks like. So I'm going to rearrange it to the y equals mx plus c format. That's where y is on its own and everything else is on the other side. Now I've got the y on its own here. I've moved my x to the other side. It was positive x, so now it's minus x. But now I want to get it in the y equals some number of x plus or minus some number format. So I'll put the x in front of the 50. It's minus x, so I can't just swap their positions. So I've got y equals minus x plus 50, which means this is a line with a -1 gradient and a y-intercept of 50. Let's look at these lines here. They all slope downwards, so they've all got negative gradients. But which one has a y-intercept of 50? That one's 60, that one's 50, and that one's 30. So clearly it's got to be this one. And I can see that the gradient is -1. If I go across 2 squares, I go down 2 squares, right? When I go across 2 squares, I'm going across from 0 to 10, 10. And when I go down 2 squares, I'm going down 10. So 10 over 10 is 1, and this is going downwards, so it's -1. Okay, so that's my first line. Which line is this one? Once again, in this format, I can't really tell, so I want to get the y on its own so that it's in the y equals mx plus c format. Then I know what the gradient is and what the y-intercept is. So leaving the y where it is, I move the 2x to the other side. I want to have the x term in front of the number term though, so I'm going to write y equals minus 2x plus 60. And there I can see I've got a -2 in front of the x, so that's a -2 gradient, and a y-intercept of 60. Looking again at my lines, they're both negatively sloping lines, but this one has a y-intercept of 30, this one has a y-intercept of 60. And just double checking, when I go across 1 square, I have to go down 2 squares. I've got the same scale on my y-axis and my x-axis, so that means that my gradient is a rise of -2 because it goes down 2 squares every time I run across 1. So it's -2 divided by 1, so that's -2. Or if we actually use the scale here and we say, I'm going across 5 and I have to go down 10. That's -10 over 2, sorry, -10 over 5, which is also -2. Okay, so I've got my 2 lines here, and I can clearly see where they cross. That point there is the solution to the simultaneous equation. So that means that the x value is equal to 10, and the y value is equal to 40. You can check that these coordinates work on both of those lines. I am sure that they do. When x is equal to 10 and y is equal to 40, 10 plus 40 makes 50, and I knew that because I got that as a coordinate point off the blue line. And also, if x is equal to 10 and I put it into this equation, y is equal to -2 times 10, -20, plus 60. That's -20 plus 60 is 40. Or in here, 2 times 10 is 20, plus 40 is 60. So this is going to be a point on the green line as well. And that I already knew because I chose the one point that is on both lines. Another proportion problem in this exam. They really want to trip us up with the proportion. Now we could set this up in several different ways, but as we've been learning how to set up the proportion formula, let's do it that way. So Angelina, Lottie, and Manuel all buy petrol. They all pay the same price per liter, so it costs the same amount per liter. Angelina buys 18.5 liters and pays $27.01. Lottie pays $40.15 for her petrol, and we don't know how much petrol she got. And Manuel buys 28.3 liters of petrol, but we don't know how much he paid. So the big hint at this is Angelina, because we know how much she bought and we know how much she paid. So she's going to help us to figure out what our formula is. Let's start with our formula where I've used the letter C to represent cost and P to represent petrol or liters of petrol. And K again is my constant of proportionality. So I was basically saying that the cost of the petrol is some multiple of the number of liters of petrol. That should make logical sense. The more liters of petrol we buy, the more it will cost. K would be how much it costs per liter. Right, so let's substitute into this what we know from Angelina. We know that Angelina bought 18.5 liters and it cost her 27.01 cents. Okay. So let's substitute that into the formula. I put the cost that she's paid in for C, and I put the amount of petrol that she bought in for P, and I'm trying to work out what K is, so I need to get K on its own here. I've taken the 18.5, which was multiplying on this side, to the other side and divided by it. So K works out to be 1.46. Now that's exact, I didn't round it. K is 1.46. So that gives us a formula of the cost is equal to 1.46 times the number of liters of petrol they bought. If I bought 1 liter of petrol, that would cost them 1 times 1.46. So that's basically the price per liter. So now we need to work out who buys more petrol, Lottie or Manuel. Well, let's have a look at Lottie. Lottie pays $40.15. So I could substitute that value in for the cost, and then I could work out how much petrol she bought. Okay, so I need to rearrange this to get the P on its own to find out how many liters of petrol she bought. That was multiplied by 1.46, so I'll divide by 1.46, and P is equal to 27.5. Now I don't really need to do any more work here because I already know that Manuel bought 28.3 liters of petrol. If Lottie bought 27.5 liters of petrol, clearly she bought less than Manuel. So who buys more petrol? Manuel. Make sure you show this working as part of your answer.